Hello everyone. In this video, we are going to discuss the occurrence of groundwater. That where does this groundwater occur on the Earth's surface? So let's start. So till now we have seen that whenever the precipitation is occurring on the Earth's surface, and when we say the precipitation, we are majorly talking about the rainfall. So that rainfall which falls onto the Earth's surface that percolates through the ground surface into the deeper portions of the Earth's surface. And when it is passing through the ground surface, it is passing through the voids of the rocks, and ultimately it joins the water table. So if you look at the rocks which are present beneath the Earth's surface. So let's say there are number of arrangements which may be possible for the rocks. So let's say the rocks are available in this certain pattern. So depending on the availability of the space, the water percolates through the empty space which is available. And this empty space is nothing but the voids which are present within the rocks. And below this there will be the water table, and ultimately it will be joining that water table. So these voids are generally interconnected. Only then there will be the continuous flow, and it will be permitting the movement of the groundwater. But in some rocks which may be isolated, that means if a large rock is present, that means if that rock is only the one which is present, and if it is present between the voids, then it may prevent the movement of the water between the interstices, that means between the voids. So the mode of the groundwater, where this groundwater will be available, so this occurrence of the groundwater, it depends largely upon the type of formation. That means what is the structure of the rocks, whether there is voids available in the sufficient amount or not, that will dictate whether the groundwater will be occurring below the earth surface or not. And therefore this groundwater occurrence depends upon the geology of the area, and the possibility of the occurrence therefore is summarized to two geological factors. If that is available, that means the chances of groundwater being available are high. So the first factor that decides the availability of the groundwater is the porosity of the rocks, and the second factor is the permeability of the rocks. Now what are these terms? So first one is the porosity. So this porosity of a rock, it is a major geological criteria for the occurrence of the groundwater, and it in itself is a quantitative measurement of the interstices or the space or the voids which is present in the rock. So if we want to define the voids within the rock quantitatively, the term of porosity is used. Then how is it defined? So it is the ratio of the voids which are present in a given volume of the aggregate to the total volume of the aggregate. So mathematically it is written as porosity is equal to the total volume of the voids in the aggregate. That means the volume of water that is required to saturate the dry sample. That is enough water if that is available within the voids. So the volume of voids that is represented by VV, and the total volume of the aggregate that is represented by capital V. This porosity is denoted by the letter N. Now this porosity therefore will be depending upon the shape, the packing and the degree of sorting of the component grains in a given material. As I've told you that if the voids are available, that means this packing of the different components, if all of these spherical surfaces, they are the component of a particular material, then the packing and the sorting and the shape of these material, that will dictate the term of the porosity, whether the rock is porous or not. If they are uniform and well sorted, that means volume of the voids that is available, that will be higher. But if there are irregular shape that is available, for example, if there is triangular, angular and spherical surfaces, all of them are available, a mix is available, in that case, that leads to the lesser void space which is available, because ultimately if the all type of sizes are available, then there will be lesser void which will be present, because whatever space was left, that will be fulfilled by one or the other component. So that's why when we are having the heterogeneous grains, that will decrease the porosity. So that was the first factor. Now, as we have discussed that this groundwater, it can get stored in the underground rocks only if they are sufficiently porous. So if the rocks are porous, that means if the voids are available within the rock, then the groundwater can get stored in that. So ultimately what is happening, this water is getting stored in the pores which we are calling as the voids of the rocks. So this porosity can also be defined as the maximum amount of the water that can be stored in the rock. That will be termed as the porosity of the rock. But it should be understood here that the porosity in itself, it does not ensure the storage of the underground water, because the water can enter into a rock only if the rock is permitting the flow of water through it. Because from the last image that I have drawn, that is a magnified image only, because if you are looking at a rock structure, you would not be able to visualize, you would not be able to see the voids present in the rock with such huge margin. So that is the internal property. This porosity is not visible. But if the rock is permitting the flow of water through it, that depends whether the rock is permeable or not. This permeability therefore is defined as the ability of a rock or the unconsolidated sediment to transmit or pass the water through itself. That ability of the rock is known as the permeability, whether the rock is permeable or not. Now, related to this permeability, there is another term that is known as the transmissibility, whether the water is transmissible from the depth of the soil or not. So the capability of the entire soil, that is known as the permeability. But if we are talking about the soil which is having the unit width and full depth, so one of the component, let's say if this is the width B and depth is D for the soil sample. So if we are talking for the entire area, that will be representing the permeability. But if we are taking the one of the dimension as unity, then the term that is representing the water flow, that is known as the transmissibility. So these are the basic terms that dictate the availability of the groundwater. Then the next is the drainage of the groundwater. Now what do we mean by this term? It means the extraction of the water from below the water table. Now what are the different mechanisms through which we can extract this water? So it can be extracted through the wells, through infiltration galleries or these springs, and there are any other methods which can be employed to extract the water from the earth surface. So let's say this is the water table. So you might have seen that these are the structure of the open well through which we hang a bucket, and from this open well we extract the water out of it. So that is an example of the open well, and the water is extracted out of the ground surface. And if the water is available between the two confined surfaces, that means water is under pressure. So if we provide any opening to it, then under the pressure it pumps out, and then it forms the spring, the natural spring. So if the water is drained from the groundwater reservoir under the natural phenomena, that is like spring, or artificially by the construction of the wells and then lifting the water through them. Now this water which is drained in that way is used to fulfill the irrigation demands or the municipal needs or the domestic needs. Then next is the groundwater yield. That means what is the proportion of the water that is available to take out from the storage of the groundwater. So the interstices or the voids which are present in any given formation and the given structure, they get filled up with the water during the process of the groundwater replenishment. This replenishment term is interchangeably used for the recharge. Now recharge means we are again charging the groundwater. That means once we have extracted the water out of the ground surface, if the water is fulfilled in those voids again, that is what we are meaning with the groundwater recharge. Now if these voids are completely filled with water, then it is known as a saturated formation. Obviously, if all the voids are present and if all of them are fulfilled with the water, such structure is known as the saturated one. Now water which is contained in these voids is drained out by digging wells under the action of the gravity drainage. Now when these saturated formations are drained under the action of the gravity drainage, it is usually found that the volume of the water which is coming out, that is not actually the volume of the entire void space, which is indicated by the porosity, because the water which is contained in these voids, it cannot be drained out by only the force of gravity. So this entire water is not coming out. Some of the water is retained by these interstices due to their molecular attraction, and such amount of water which is retained against the gravitational flow is known as the pellicular water. So if we look at the structure of the groundwater, there are two types of the water which is available. One which can be extracted directly under the gravitational flow and is known as the gravity water. Other one which cannot be extracted under the gravity and is known as the pellicular water. Now to study whether we can extract that water or not, there are few terms which can be studied. First one is the specific yield. So from the entire volume of the voids, the volume of the groundwater which can be extracted by the gravity drainage from the saturated water bearing material which can be taken out, that is known as the yield. And if it is expressed in terms of the volume of the total material which can be drained out, then the ratio is known as the specific yield. So for example, we are having the total volume of the material as 100 units, out of which the volume of the material in which the water is present, that is 70 units, and out of that we can extract the 40 units. So the volume of the water which is obtained by the gravity drainage, that is 40 units, while the total volume of the material which is drained or dewatered, that is 100. So that is the specific yield. The second of the term is known as the specific retention or the field capacity. Now the name itself suggests what does it mean. So the quantity of water which is retained against this pull of gravity, that is known as the specific retention or field capacity. And it is also expressed as the percentage of the total volume of the material which is drained. So this specific retention or the field capacity is the volume of water which is held against the gravity drainage. So we have studied this example that where this 70 units of water was available under the gravity drainage. We could only manage to extract the 40 units. That means the 30 units was retained. So this is the volume of water which is held against the gravity drainage. The total volume of the material which is drained, that is still 100. So the specific yield was 0.4 or 40%, while this specific retention was 0.3 or the 30%. Now if you look at the addition of these two terms, that is 40% and this 30%, so this specific yield, that is denoted by SY, and the specific retention, that is SR, the total value of these two is 70%. So this 70% is 70 by 100, where this 70 was the total volume of the voids, that was 70, and 100 is the total volume of the material which is drained. Now in the saturated condition, this 70 is the total volume of the voids, because in this entire volume of the voids the water is present, and the total volume of the sample, that is 100 units. And this ratio is known as the porosity. So it is evident that the sum of specific yield and the specific retention is equal to its porosity. So that completes the discussion regarding the occurrence of the groundwater. Now in the next video, we will take a look at the different types of aquifer. Thank you.